So the topic we should be treating today is Introduction to Statistical Analysis. And at the end of this section, you should be able to apply connected paper software in your research. Actually, this is the aspect I'm supposed to have added to the previous section, but it's still okay. You can still see how to make use of that particular tool. So, and also, you should be able to describe statistical analysis. You should be able to highlight type of statistical analysis, descriptive and inferential, and where can they be applied in your research. Then you should be able to define research population with appropriate examples. You should be able to describe population sample and sample size. You should be able to compute research sample sizes. And you should be able to define research variables. And finally, you should be able to highlight the major types of research variables with appropriate examples. Okay, so to start with, we quickly look at a tool known as connected papers. Actually, this tool, what it does is that it allows you to, let's say you have a particular topic, and from your topic, you have been able to determine your keywords. So once you type in the keyword on this platform, it traverses the web and pull related papers, okay, in that particular field and show them to you. So it's not left for you to choose the one that is really, really close to what you are looking for in terms of your research. So it's really helpful when it comes to, let's say you want to write a publication, or you want to get some ideas, you want to know what is currently going on in your area of research. So connected paper can help you to find similar academic papers that are relevant to your work very fast. Okay, then when using connected papers, you can understand a brand new academic subjects, because that is where you're going to see the popular topic that people are discussing in your field of study. And also, you can also develop your visual awareness of the current trends. That's in terms of graph, like what you're seeing towards the right on the screen. Then, excuse me. Okay, what you're saying here. Well-known articles and dynamic movement within your chosen topic. You can see them. You can see the most prominent articles in terms of, I think I need to, excuse me. Oh. Okay, so well-known articles and dynamic movement within your chosen topic. Then all you need to do is to enter a typical search term or keyword, and connected paper will create a graph of similar documents in the area for you to look at. And it also allows you to see papers you don't find on search engines like Google Scholar and other search engines. Okay, these among others are the advantages that can be derived from connected papers. Also, so how does it actually work? All you have to do is to go to this link. Just type connected papers on your browser, and the first link that will come will be connected papers. So all you have to do is to open the link. Once you open the link, that will bring you to this page. So from this page also, you can navigate to other search engines such as PubMed, Market Scholar, as well as AHRXIV. Okay, so now, once you are on this page, all you have to do is to type in your keyword, okay, or search topic, something like that. You can type them in here. Then you click on build a graph. Now, once you do that, that will take you to something like, let's say, for example, I entered health informatics. Okay, after entering health informatics, I click on. Actually, when I type health informatics, there will be some kind of suggestions. Okay, some suggestion will be displayed. So if any of them relate to what I actually need or what I'm looking for, I can straight away click on it. Okay, but if none of them look appealing, all I need to do is just click on build a graph button. Now, when your first search result comes out, make sure you choose the most relevant article to your research. That is, when you have all these options, if you can find any of them interesting or related to your research, you can choose any of them. But if you cannot, no problem. Just leave the keyword like that and just click on this button. Okay? Connected papers will build similar documents in this regard. That is, it's going to grab all the related papers to this particular keyword you are searching for. Okay? Then at the end, you will get something like this. Okay? So now, when you get something like this, you can decide to open a given source. By the way, if you look at this place, this is a graph. This graph tells you a lot of information. And towards the left panel, you have a list of publications. All these publications made up this graph. On this graph, each circle you're seeing represents a particular article. And the bigger the article shows the number of citations that article has. And of course, the higher the number of citations shows how popular that particular article is in that particular field of domain, research domain. So you can decide to open a given source using connected papers, semantic scholars, DOI, or Google Scholar. Those options are here. All you have to do is select any of the papers here. For example, I chose this one, Health Informatics in Developing Countries, going beyond pilot practices or sustainable, whatever. So it's here. So I can decide to open this particular paper in any of these options. Excuse me. Then, if you look at the graph again, it shows you all similar papers. That is, papers that goes in line with my search criteria, which is health informatics. So all the papers I'm seeing here actually say one or two things about health informatics. So they are all related. Okay, so the size of the circle, like I said earlier, is determined by how many times the work has been cited. Okay, take for example, this one now, we have the corresponding author is D. Luna. And this particular article has been cited 112 times. Okay, and that's why you can see the size is a bit small. I've seen some people that has about 270,000 citations, and as a result, it makes the circle really, really big. Okay, and that kind of paper, that this kind of paper is a widely known paper in that particular field of study. Okay, so if you want highly cited material, click on the bigger circles. That is, if you want those papers that are well known in your area of research, then you can click on the bigger circles. You can get paper that cited many of the documents in the graph from the derivative works. If you look at this place, you have two buttons. One is derivative work, one is prior works. So if you want to get a paper that cited many of these documents, okay, then you can look at them in here. Then if you now want to check articles that this document actually cited, okay, the document that these papers cited in their references, then you can look at prior works. Okay, so meaning that the research that has been done, the foundational research that this author actually check before they come out with their own work, you can get those ones under the prior works. But if you look at the research that has grown as a result of this, then you can check them from these derivative works. Yes, please. Is there a filter to apply? Uh, filter, it depends. I don't know. I've never tried to filter any of the results because what we are trying to do, the aim of connected paper is that to show you the popular articles and related articles in your area of keyword that you are searching for. So, and with that, you can concentrate on those results that are displayed. So it's not left for you to choose which one that you actually need. Okay, but there's no crime, you can still check. Also, if you look at this somewhere here, it tells you whether this graph is outdated or not. Because sometimes, if you open a particular, let's say you search for a particular paper, and it is, of course, the graph will be built automatically. But if there are new paper in that area, but has not been updated, it will tell you here that that graph is outdated. So all you need to do is to click on that graph or that outdated message. Then it's going to update the graph for you by including the new articles. Then, as a result, you may have additional nodes in the graph. So all you need to do for a particular one, let's say you want to check any of these paper, you just click on any of them, then you can see the details somewhere here. Okay, so let's see. Now, how do we now open article on this part? How do you open article on this platform? Now, the first thing you do, like I said, let's say I want to go by the size of the circle. This one seems to be a little bit big, and at least compared to the size, so meaning that it's quite relevant, it's quite popular in this area. And if I click on it, of course, this is the name of the paper, Health Informatics in Developing Countries, going beyond pilot practice to sustainable. Blah, blah, blah. So now, if you look at this page, it has about 200 citations. Okay, so now I want to check on this paper. So once I click on this, then I can see a brief description or information about the paper somewhere here. Okay, so the first thing you do, like I said, you click on the relevant document that appeal that is related to your research area. From there, you can see the abstract, number of citations, as well as references. Now, if you now want to download, after you have read the objective of the paper, that's a brief description about the paper, you can, if you now want to download that particular article, all you need to do is to click on the topic here, the title. So when you click on this title, this will open a new page for you, somewhere like this, under Semantic Scholar. Semantic Scholar is another example of search engine where you can get a lot of articles or research materials, you want to call it. So now, once that particular paper is open here, if you see the PDF, you can try the PDF and see whether it's going to download straight away. That is if the paper is available for free. Okay, and if you cannot do that, it's fine. You can copy the DOI number and straight away go and download it from Skyhub, or you can use your Mendeley importer plugin. So once you launch that, then you're going to see the list of articles on the page, which is basically this particular one. Then you can select it and add it straight away to your library. Okay, this is how to get this particular article. But remember, if this is all you did, if this PDF is what you downloaded, then you need to go and add it manually to your Mendeley reference manager. Okay, so this is how to export and cite paper on that particular connected paper tool. Okay, so remember, the bigger the size shows how prominent the article is. Okay, so let me quickly walk you through. Sorry, Okay, so I just go to connected papers. So you see something like this. Okay, so you click on this. So you have this. Okay, so if I want to search for, let's say, statistical, let's say statistical, or say something statistical or something like this, or something like this. Now you see the way the graph is generated. So if I hover my mouse here, you see, based on whichever one I'm choosing, says the description and title is being selected. But this one is big. This one is meaning that this particular paper is super popular in this particular area. So if I hover my mouse on it, let's say I select this, for example, it has about 110,826 citations. That shows you that this particular paper is popular in this area. Then we have other related articles as well that can be explored. So if this is what I want, I can straight away, sorry, some people are joining the class. So if this is what I want, I can straight away just click on the title, and that will take me to this page. Sorry, it's loading. Still loading, Cool. My internet is down, please. Okay, so now we're here. So now I have my article. So if I like, I can straight away, I can view in publisher. I can, if all I need is the site, then I can click on the site, and I'm going to see some of the citation. Let's say I need the APA citation, but I need the paper itself. So I can, if you scroll down, there are other similar articles to it that you can actually explore. But this particular one is what I want. So I can't find any PDF here, so there's no how I can download the paper on this page. So all I need to do is I can straight away copy this DOI number, okay? Or I can use my plugin. Okay, I can use my plugin to sign in. So, okay. So it's asking me to sign in. So let's click on sign in. Then I entered my, this is because I'm just logging in. It's been a while. Okay, so I just sign in. Okay. Okay, while this is moving, another way, let me just copy this. Let me see the one that's faster. So, so I have this. I put this one in here. I click on open. Oh, this is still trying to log in. What? It's taking so long. So, while this one is going, this has already opened. Okay, so this one is, sorry, my internet is, shouldn't be this slow. Okay. So now I got the paper. Let's go down here. It's just a 2-page paper, and it has that huge number of citations. Book review, readers invited, statistical analysis for this. This is what I'm getting here now. Visual access. So that's what I got for this particular one. So from there, I can just download. I have it here. Okay. So with that, I can straight away download it. I mean, I can add it to my Mendeley reference manager. And of course, this one has also, I think I had issue with my VPN. Yeah, that was why it was giving issue. So now, that is how, so any article you get on this place, that is how you can download them or add them. So that you use SkyHub, or you can straight away use your Mendeley importer plugin. Okay. So, but again, one of the most important thing here is that this tool will give you relevant related article to your research. So it will save you from citing articles or papers that are not closely related to your field of research. Okay? And of course, you have many of them that you can explore, you can go through and see, you can select any of them and see, read about them, then from there you can open them. Then you see all these ones. Okay, so the choice is here depending on your research and how relevant it is to your area of findings. Now, I would say that let's quickly look at the basic flow of research. Every research, you will have some kind of question you want to address. You want your research work to answer. Okay, so meaning that you need to prepare your research question. You need to decide on, study design as well as sampling strategy. Then you also need to decide on your mode of data collection. How do you want to collect your data? Of course, you need to first identify the kind of data you want to collect. Remember, whatever data you are collecting must answer this research question, which I believe they will have explained this to you in your Saturday classes. Now, after you have collected this data, you need to organize those data and do some kind of data analysis. So based on the outcome of those analysis, you need to draw your conclusion and of course, present your conclusion. You need to discuss the result and present your conclusion. This is the basic flow of a research work. Starting from the research question. So now, let's look at what are the things that this statistical analysis has to offer us. When we say statistical analysis in general, you can describe it based on your context, based on your research area. But generally, you can say statistical analysis is can be described as investigative trends, okay, patterns, and relationship using quantitative data. You can describe a statistical analysis just like that. And you also understand that it is an important research tool used by scientists, government, businesses, and other organizations. So that is why whenever they want to make certain decision, they'll ask you to carry out some research. Take, for example, if these big companies like Apple or Samsung want to release some kind of products, they have to carry out certain research. And after they have collected people's opinion, then you have to aggregate all this opinion in order for them to know what kind of products should be create or produce. and release to the market. Because it doesn't make sense creating a product that will not be accepted or welcomed by the user. So as a result, they have to do some kind of research and aggregate people's view. Then from there, incorporate that into their development policies. Now, to draw a valid conclusion, statistical analysis requires careful planning from the very start of the research process. So, meaning that you just have to get it right from the very beginning. If you did not get it right from the very beginning, there's no shortcut. You have to go back and redo. And that is why the foundation is you have to understand your research problem. You have to formulate a strong research question. And you must be able to identify the kind of data that you need to answer those research questions. And after you have identified the kind of data you need, your mode of data collection, your method of data collection also matters. Is it feasible? Is it easy to get? How do you want to go about it? Then, who are your target group? Who are the people you want to sample? I mean, who are your population? Where do you want to get this data from? Are they accessible? So these are many others are what you have to put into consideration before you get to statistical analysis stage. But if you just jump to statistical analysis stage, then and you fail to consider all those affirmation points, you have to go back and redo, because there's no magic, there's no shortcuts. Okay, now you need to specify your hypothesis and make decision about your research design, sample size, and sampling procedure. Okay, after collecting the data from your sample, you can organize and summarize the data using descriptive statistics, which is a very basic and very simple, easy to do. Then you can use inferential statistics to formally test hypotheses and make estimates about the population. Okay, remember population here, anyway, we discussed about population in the short term. Then lastly, you can interpret and generalize your findings based on the result of your analysis. Okay. Also, you can further describe statistical analysis as the art and science which deals with the development and application of the most appropriate method for collection of data, okay, presentation of the collected data, and analysis and interpretation of the results, and lastly, making decisions on the basis of such analysis. These are various methods by which you can use, or various ways by which you can describe statistical analysis. But again, before you get to this stage at all, you must have foundational knowledge of your research, meaning that you must establish the problem you want to solve. Your research question, you must formulate from the problem. There's a procedure on how to formulate a research question, which I believe they must have mentioned to you in your Saturday class. But again, I can still show you the process of how you can formulate your research question. I will give you the steps to guide you on how to formulate a strong and relevant research question. What are the components you need to put together to make sure that you come with a feasible research or achievable research question? Then after you have gotten that, then you have to think of how do you want to answer this research question. Because whatever activity you want to do, your goal is how to provide answer to those questions. It may be one, it may be two, it may be three, depending on how complex your research is, depending on the nature of your research. Research question may be one, it can be two, it can be three, it can be four, it depends. Okay, so then after that, then you have to decide. I mean, you have to identify what are the kind of data you need to answer those research questions. And after you have determined that, you have to also determine your method of data collection. After you have determined that, then you have to make sure you have to identify your target group, which are basically your population. It's not necessary to be human. Population may not necessarily be human being. Okay, it can be anything. We are going to discuss about that in a short while. Okay, so you have to identify your population size. Then after that, then whether you want to research or you want to check, you want to cover the whole population, fine. Or if your population cannot be covered, then probably you can take what is called sample from that population. But of course, it has to be a representative sample. We'll be discussing about that. So you have to identify all these things. Once you have done that, then only then you can think about how you want to collect your data collection method. Then once you have concluded on that, you can go ahead with your data collection. After you have collected your data, you still have to clean the data. After you have cleaned that data, then you can now move to analysis. Okay? But what statistical analysis is what I've just been describing here. Now, we have various types of statistical analysis. Okay, so basically, when we talk about data analysis, we have two major categories. We have descriptive analysis, which are used to describe data. Okay, whenever you see some kind of analysis that says 50% or 45% are females, 80% are males, or 20% is red, 25% is yellow, so whatever is this. Those are examples of descriptive analysis. Okay, then we also have inferential analysis. Inferential analysis are used to infer conclusions and hypotheses. You can use inferential analysis to investigate relationship. You want to find out whether there's a relationship, whether a significant relationship exists between variable A and variable B. Then you can use inferential statistical analysis. Okay? Then you can also use inferential statistical analysis to compare, to do some kind of comparison between groups. Okay? Whether you want to check the mean, whether they have the same mean, or probably they don't have the same mean, or whether their mean is equal. So then also you can use inferential statistics to predict, okay, to do some kind of predictive analysis. Okay, these are some of the analysis that can be done using inferential statistics. Okay, then when we now talk about descriptive statistical analysis, it comprises of the method used to describe the collected data. Okay, then it deals with organizing and summarizing data using numbers and graphs. Then it involves various processes such as the tabulation. You can describe your data in form of table. Okay, a measure of central tendency, which include means, median, as well as mode. A measure of dispersion or variance, which could be range, variation, or standard deviation. And also, you can also check for skewness measurements as well as time series analysis. Okay, these, among others, are what you can do under descriptive statistical analysis. Now, what the major drawback of this particular analysis is that it only allows you to make summation about the object or people that you have measured. Okay, and some of the operations, some of the kind of analysis that can be done here, you can check for population mean, you can check for sample mean, you can check for weighted mean. Okay, you can check for sample mean of group data, mean deviation, population variance. But of course, you don't have to worry about this formula because that is only if you want to do it manually. Remember, we'll be using SPSS. SPSS will help you with all these things. You just have to have the data. Once you have the data, then it's just a matter of click, and you get your work done. Okay? Now, also, we have various types of descriptive analysis, which can be further divided into mathematical descriptive, which is basically equation. Then you can have a graphical descriptive. You can have tabling descriptive. Okay? So when we talk about mathematical descriptive, we can have central tendency, like I said earlier, which includes sum, mean or average, mode or median. Then we can also have dispersion descriptive, also under mathematical descriptive, so which can be range, variance, and standard deviation. Okay. Then graphical descriptive, you can have pie chart, you can have bar chart, you can have box plot chart, you can have line chart, you can have curve chart, you can have scatter plot chart, you can have histogram, and many others. Okay, so this falls under graphical descriptive. Then we also have table descriptive, which is mostly like this. Okay, in a tabular form. Sometimes it can be a simple table, it can be a complex table. So it depends on the kind of variables you have in your research. Now, inferential, that's that on descriptive statistics. Now, inferential statistical analysis is used when the inspection of each unit of the population is not achievable. Hence, it extrapolates the information obtained to the complete population. So take, for example, you want to do a research that has to do with the population of a country. Of course, we don't expect you to start going and meet, we don't expect to meet each and every citizen of that particular country. Take, for example, you want to do a research that has to do with Malaysia, for example. Malaysia population is about 34 million plus. So we don't expect you to be going and meeting one after the other, meeting one person after the other. Some people will not even be accessible, so which may be quite difficult. So then what we do here is that you can now, instead of going after everybody, then you can now select what is called sample. Okay, but that sample must be representative sample. Okay, that sample will be the one that represents the entire population, meaning that whatever your analysis is for that small sample can be applied to the entire population because it's a representative sample. Of course, there are some issues, there are some constraints, there are some criteria that you need to put in place before you select a particular sample. I'm going to talk about that in a short while. Now, it is a result of more complicated mathematical estimation and allow us to infer trends about a larger population based on samples of subjects taken from it. It is used to study the relationship between variables within a sample, and you can make conclusion, generalizations, or prediction about a bigger population. In other words, a sample accurately represents the population. A sample accurately represents the population. So lastly, it allows businesses and organizations to test a hypothesis and come up with conclusions about the data. Okay, that's what inferential analysis allows us to do. Now, let's look at the search population. Population can be described as the largest collection of values of a random variable for which we have an interest at a particular time. Okay, it can also be described as the entire group that you want to draw conclusion about. Okay, in research, the population doesn't always refer to people, like I said earlier. Example of population could be mark of all the children enrolled in a school. That could be or the price of different car models, okay, in different cities. That could be population. That could be your research population. Or population may be finite or infinite, meaning that you can have odd numbers greater than 3, but less than 99. You can also have odd numbers greater than 5. All this can be an example of population. And again, population can still mean people. Okay? It depends on the nature of your research. Now, population sample. Population sample is a part, or you can say a portion of a population. Like I said, you want to carry out a research that has to do with all the citizens of Malaysia. We don't expect you to start administering your questionnaire or whatever to each and everybody you meet on the street of Malaysia, because some people may not be accessible. So for some reasons, so as a result, you will not be able to collect data from an entire population. So the only thing you can do, and again, you will be spending more time, more effort, more money. It could be super, super expensive. So instead of going through, and at the end of the day, you may not even achieve a better result. So instead of going through this particular process, then we can straight away use what is called population sample, which is a portion of the entire population in Malaysia. Okay, a sample is the specific group that you will collect data from. Okay, you are not collecting data from the entire population in the country. So you only select a sample, some parts of that population. That little part of that population is referred to as population sample. The size of the sample is always less than the total size of the population because, of course, it's smaller. Okay, and it is a subset of a population selected for measurement, observation, or questioning to provide statistical information about the population. For example, okay, the marks obtained in mathematics among the students in year 5 can be an example of a sample, can be a population sample, or the body temperature of male patients in clinic A for 3 days. That could be an example of population sample. The monthly income of bank managers in Kuala Lumpur. That could be an example of a population sample. Okay, so it is very important for you to choose a representative population sample, because whatever inference you are drawing from this population sample should be applicable to the entire. You should be able to generalize whatever output of your analysis is to the entire population. But that can only be done if you choose a representative sample. Now, another term, there's something called sample size. You said, like I said earlier, population of Malaysia is about 34 point something million, if I'm not mistaken. So now, how do you determine what your population size will be in this case? Yes, you say you cannot collect data from the whole population. Then how do you decide? How do you determine your sample size? Because these are the things they will ask you. You cannot just say that, okay, because the population is large, so I just said to choose 200 people or 300 people or 400 people. You need to have a basis. You remember, research is all about evidence, all about proof. It's not opinion. It's all about facts. So you need to make sure that you establish your reason for choosing a particular sample size. So how do you determine your sample size? Sample size is a research term used for defining the number of individuals included in a research study to represent a population. Okay, by sample size, we understand a group of subjects that are selected from the general population. Okay, and is considered a representative of the real population. Okay, representative of the real population for that specific study. If it is not a representative of the real population, then there will be issue at the end of the day. Okay, so make sure that whatever sample size you are choosing is a representative of the real population. Now, what are the points to note in this case? One, if the sample size is too small, okay, if the sample size is too small, it will not yield valid results or adequately represent the realities of the population being studied. Okay. Two, large sample size yield smaller margins of error and are more representative. Okay, but you need to remember that a sample size that is too large will significantly increase the cost and time taken to conduct the research. That's another thing you have to put in consideration. A well-known sample size calculation formula is ambiguous formula. This is a popular formula that they normally use to compute sample size, which can be applied through deciding the population size, specifying the confidence interval, defining the confidence level, determining the standard deviation, and converting the confidence level into a z-score. That look complex, right? That look complex will be like, oh, how will I determine all this, especially for those who are not from mathematical background. Don't worry, there are a lot of tools that can do that for you. Okay, so the approach to determining sample size depends on the specific research aim of the study, the number and nature of the variables involved, okay, the data collection or sampling method, and the intended method for analysis. That will determine what you want to use for your sample size. So, but if you want to do it manually, this is the formula for calculating sample size. But again, you don't have to worry about this. There are a lot of tools that can be used for this purpose. Now, and one of them is RAWSoft. Okay, RAWSoft is a tool that allows you to calculate the sample size. All you need to do is just go to that site called rawsoft.com. So then click on option called sample size. So that will take you to this place, or you can straight away just type in this particular link. So that will bring you to this page. So once you get here, what margin of error can you accept? Basically, they always advise that we use, among most of the research paper you'll be getting, majority of the power is 5%. Then what confidence level do you need? You either use 90%, 95%, or 99%. Then what is your population size? Then you can put your population size here. Okay, and what's the response distribution? So this one, they always advise you should buy 50%. So then with that, if you go with this, then your recommended sample size will be 377. 377. So this is how you can determine your sample size. So you don't have to worry about the formula that was shown to you earlier. So with this, you can get your sample size done within a few seconds, just a matter of click, 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 click. Okay? There's another method, there's another tool that can be used, which is easy calculation. So here also allow you to calculate your sample size. All you need to do is also put your confidence interval level as well as population. Then you click on calculate. Okay, your sample size will be displayed. Okay, so these are the methods, but of course, I always prefer to use RAWSoft because it's a bit straightforward, and of course, it has a lot of additional information for you to understand what you're trying to do. Okay. Now, other types of statistical analysis include, we have talked about descriptive analysis, which basically talk about what happened, okay, and figure out what is going on. That's why you can see what is the color in terms of how many color do you have in the population. Can be, let's say you are looking at a particular objects, then yellow is 20%, this is this, all those kind of basic kind of descriptive statistics. So then basically descriptive analysis is all about what happened. Then you can also have diagnostic analysis, okay, which is focused on why did it happen, okay, why did this happen. Then we have predictive analysis, which is what is likely to happen, okay. Then we have prescriptive analysis, which is what is the best solution to what has happened, okay. These are the major type of analysis, other type of analysis that are available. So I'm not saying that you're going to apply all in your research work. Basically, descriptive is always essential. It's kind of common in every research. Then the other one depends on the nature of your research work. Okay. Now, we also have research variables. Okay, we have research variables. A variable in research simply refers to a person, place, thing, or phenomenon that you are trying to measure in some way. Okay, a variable's value can change between groups or over time.
So, Professor.
Yeah, please.
Yeah, I just want to maybe just a little bit to take you back on the sample. Sometimes sampling how to get the sample size.
Okay.
Yeah, sometimes I use the table, which is the Morgan and Craig table of 1970. Does it still apply?
Okay. Yeah, it's okay, it's fine. But if you are comfortable with that, and you have sufficient literatures that use the same tool, yeah. Okay, you have to reference those literatures in your writing. Okay, take for example, because you have to tell us how you determine your sample size. Okay,
yes.
So, and based on what you have used, you need to get supporting literatures where researchers have used that same tool. Okay, then you have to reference it in your writing.
Where other researchers have used the same?
Yes, where other researchers that have used the same method in their work. Okay, you have to cite those papers in your work. Otherwise, there's no how you can convince your examiner or your reader that this tool is actually relevant, because they will expect you to use the current tools or tools that are widely known. Okay.
Maybe another question. When I go on this sample size calculator, how do I cite it?
This one is popular in research area in the domain of research. This particular one, this one.
Like yes, Microsoft. How do I cite it?
There's a way you cite a web page. Okay, there's a way you cite a web page in your research. So you need to find out how to cite a web page. I believe they will teach you how to prepare all this. But again, all you have to do in this place, for example, you can open your Mendeley importer. That will extract this for you. Once that is done, it's inside your reference manager. Then wherever you want to say something about your sample size, put your cursor there, then select that reference. It will insert there automatically. So you don't have to worry about how to cite this. As long as you have imported it into your list of libraries, then Mendel will take care of the rest. You get it?
Yes, I get it.
Okay. So just make sure you get it inside you import it into your Mendeley reference management tool. Then from there, you can cite just like the way you do your inside in-text citation. Then the software will take care of the remaining part for you. Now,
sir, can I ask?
Yes, please.
Yeah, sir, I understand you asked that the population size and sample size. Is it necessary to have a population size, or I can take directly only sample size? Because my project research is on a case study, which I am doing practically on my clients.
Irrespective of the type of research you are doing, you must have a population, you must have a target group.
Okay, okay.
So that your target group is your population.
So target I will be deciding?
Your target group, it depends on the nature of your research. If your target group is small.
Yes, small, it's small.
If it's small, then you can, and you think that you can actually cover all of them. I mean, you can sample, you can collect data from all, then it's okay.
Mm-hmm.
But in a situation whereby the population size is large,
mm-hmm.
it's not achievable.
Okay.
Then you can use sample size.
So my sample size would be around between 100 and 200. This is a live case study. The population,
okay.
You said I was very happy when you said there should be finite or infinite population sample size I could have. So my sample size is in between 100 or 200, somewhere around in between. So the comparison analysis is must. How can I avoid that? Comparison analysis. Because I'm not going to do any comparison. I'm going to do the patients or the clients who are coming to me. I'll do this method, so they will recover from that. So I'm not going to compare with something else. I want to project the way I am processing the results. The outcome is like this. So the comparison is not must.
Yeah, it's okay. Like what I said.
Mm-hmm.
Type of analysis you'll be doing is solely depend on the nature of your research.
Okay.
So if it's not necessary, but the only thing I will advise you is that make sure that you work with your supervisor.
Okay.
Let him or her guide you accordingly.
Okay.
But sometimes we don't, like I said, it's not necessary that all this analysis I've mentioned is applicable in your research. No, you don't have to do all. You only pick the one that goes in line with your research work.
Okay.
Okay.
Thank you. Thanks a lot.
I'll come back.
Okay. So research variable. A research variable, a variable in research simply means a person, place, thing, or phenomenon that you are trying to measure in some way. And a variable value can change between groups or over time. An example, if the variable in an experiment is a person's eye color, okay, its value can change from brown to blue to green, from person to person. Okay, it is a characteristic that takes on different values in different person, places, things, or idea. For example, okay, the age can be a variable. The cholesterol level of adult males can be a variable. The weight and height of school children can be variable. The IQ of postgraduate students can be variable. The temperature of a location can be variable. The salary of different jobs can be variable. Okay, we have different types of variables. So let's have a look at them. Now, researchers organize variables into a variety of categories. Okay, the most common of which are: one, we have independent variables. We have dependent variables. We have intervening or mediating variables. We have moderating variables. We have control variables. We have extraneous variables. We have quantitative variables. We have qualitative variables. We have co-founding variables, and we have composite variables. We have others. There are a lot of them. Okay, so it now depends on the nature of your research that will determine the one you are going to apply in your work. So let's look at each of these variables one after the other. And now let's look at independent variable. This one is quite common in most of research you will have come across. Now, an independent variable is a singular characteristic that the other variables in your experience cannot change. Okay, age is an example of an independent variable. Where someone lives, what they eat, or how much they exercise are not going to change their age. Independent variables can change other variables. Researchers often try to find out whether an independent variable causes other variables to change and in what way. So let's look at this example. We have a particular plant here. Now, the one thing you change limits to only one in an experiment. Then, example, the liquid used to water each plant can be an example of independent variable. Then let's look at this place. For dependent variable, the change that happens because of the independent variable. So, example, the height of the plants happen because you watered the plants. So the height of that plant depends on how much water you provide for the plants. Then we also have a control variable, that is everything you want to remain constant and unchanged. So that can be the pot, the size of the plants used, pot size, amount of liquid or soil type. All this can be known as control variable. But anyway, we have just discussed about independent variable. The one thing you change, okay, limit to only one in an experiment. So an independent variable is a singular characteristic that the other variables in your experiment cannot change or manipulate. Now, for dependent variables, a dependent variable relies on and can be changed by other components. Okay? A grade of an exam is an example of a dependent variable because it depends on factors such as how much sleep you got, okay, and how long you studied. Independent variables can influence dependent variables, okay, but dependent variable cannot influence independent variable. For example, the time you spend studying dependent can affect the grade of your test. Independent, but the grade of your test does not affect the time you spend in studying. Okay, while analyzing the relationship between study objects, researchers often try to determine what makes the dependent variable change and how. Okay, that's what dependent variable is all about. Then, intervening, you can see it, I can call it mediating variables. An intervening variable is a theoretical variable the researcher used to explain a cause or connection between other study variables, dependent and independent. Basically, they are associations instead of observation. Associations instead of observation. For example, if wealth is the independent variable and a long lifespan is a dependent variable, the researcher might hypothesize that access to quality health care is the intervening variable that link wealth and lifespan. Okay, so that is what mediating variables, they are more or less association. Okay, they don't stand on their own. They connect independent and dependent variable together. Now, we also have moderating variables. A moderating variable changes the relationship between dependent and independent variables by strengthening or weakening the intervening variables' effects. Okay? For example, in a study looking at the relationship between economic status, which can be independent variable, and how frequently people get physical examination from a doctor, it can be dependent variable. Age is a moderating variable in this case. That relationship might be weaker in younger individuals and stronger in older individuals. This is an example of a moderating variable. Then we also have control variables, which are actually constants. Okay, control variables are characteristics that are constant and do not change during a study. Okay, they have no effect on other variables. Researchers might intentionally keep a control variable the same throughout an experiment to prevent bias. Okay, for example, in an experiment about plant development, control variable might include the amount of fertilizer and water each plant gets. Okay, these amounts are always the same so that they do not affect the plant growth. Okay, the pot can also be a control variable. Okay, so in general, if you want to look at this three, from the first example I gave, the independent variable can be the water you're pouring, the dependent variable can be the height of the plant, and of course, the control variable can be every other thing you keep constant, like the sand, the soil, as well as the pots. All these two doesn't change. This can be an example of a control variable. Then we have extraneous variables. An extraneous variable is any variable that you are not investigating that can potentially affect the dependent variable of your research study. Okay, these unwanted variables can unintentionally change a study's results or how a researcher interprets those results. For example, a study assessing whether private tutoring or online courses are more effective at improving students' English test scores. Extraneous variables that might unintentionally influence the outcome include parental support, prior knowledge of a foreign language, or socioeconomic status. These are the kind of variables that can influence this kind of study. Okay? So that is basically what extraneous variables does. Then we have quantitative variables. Quantitative variables are any data sets that involve numbers or amounts. Okay? Example might include height, distance, or number of items. Okay? Researchers can further categorize quantitative variable into two types. They can have a discrete, which means any numerical variables you can realistically count, such as the coins in your wallet or the money in your savings accounts. And it can be continuous, which could be numerical variables that you could never finish counting, such as time. Further examples can be number of students in a class, number of square feet in a house, population size of a city, age of an individual, height of an individual, even weight of an individual. All this can refer to as quantitative variable. Now we have qualitative variables, which can also call as categorical variables. Okay, qualitative variables are non-numerical values or groupings. Example might be eye or hair color. Okay, this can be categorized into three types. We have binary variables with only two categories, such as male or female, red or blue, black and white. In this case, you can also call a binary variable, calculated variable, as being dichotomous. Okay, when we get to statistical analysis, you see how to apply all these things. But today, you just need to have the fundamental of the foundational knowledge. Now, this can also be categorized as nominal. Okay, nominal. So variables you can organize in more than two categories that do not follow a particular order. Okay, take for example, housing types. We have single family home, we have condominium, we have tiny home, okay, and so many others. So these are examples of nominal variables. Then we have ordinal variables. Ordinal variables, variables you can organize in more than two categories that follow a particular order. Nominal are those variables that you can organize, that can be organized in more than two categories, but do not follow a particular order. That's nominal. But ordinal, variables that can be organized in more than two categories, but follow a particular order. That's the difference between nominal and ordinal. Take, for example, level of satisfaction. It can be strongly agree, strongly agree, neither, or disagree, strongly disagree. You can see there's a particular order, right? So it can be unsatisfied, neutral, or satisfied. It follows certain order. So that is what ordinal variable means. Okay? But of course, it's more than 2 categories. Both nominal and ordinal are more than 2 categories. But nominal doesn't follow any particular order, but ordinal follows a particular order. Okay, so when you are selecting nominal or ordinal in your statistical data view, variable view, know when to select nominal or ordinal. Okay. Now we have confounding variables. A confounding variables is one you did not account for that can disguise another variable's effects. Okay, they can invalidate your experiment results by making them biased or suggesting a relationship between variables exists when it does not. For example, if you are studying relationship between exercise level, which could be your independent variable, and body mass index, BMI, which could be your dependent variable, but do not consider age effects on these factors, it becomes a confounding variable that changes your results. Okay? They affect other variables in a way that produces spurious or distorted association between 2 variables. Okay? That's what confounding variables actually does. Then we have composite variable, which is the final one. What composite variable is all about? Anywhere you hear composite, you are adding 2 things. Okay? So here, composite variable is 2 or more variables combined to make a more complex variable. It can be 2, it can be 3, but mostly it's always the common one is just 2, but it can be more than 2. So whenever you add 2 or more variables together to form one variable, then in that case, you are using what is called composite variable. It is made up of 2 or more measures that are highly related to one another conceptually and statistically. Overall health is an example of a composite variable. If you use other variables such as weight, blood pressure, and chronic pain to determine overall health in your experiment. As a result, overall health in this case can be referred to as composite variables. Okay, so these are the major types of variables that we have in research. Again, I'm not saying that you are going to apply all this in your research work. You only look at the ones that fit into your research and pick it, apply. Okay, but it's good for you to be. It's good for you to get exposed to all these major types of variables. Okay, so on this note, we have come to the end of today's section. So if you have any question, please let me have them. I have shared the link for the attendance in the chat box, so please check, click on it, and fill up the attendance, please. So if you have any questions, please let me have them.
Sir, can I ask something?
Yes, please.
Sir, is there any reading material like the reference book or anything from which we can get just a reading of all these variables, methods, etc.?
I mean, a lot of materials online that you can explore. And also, I think there's a particular textbook I shared with one of my and with the last set. Maybe I'm going to share the textbook too in the group so you can have a look at it.
Thank you. Thank you, sir.
But of course, it's a big textbook, right? You can straight away get a lot of resources regarding this on the site, on the internet.
Yes, sir.
But of course, I'm going to share the textbook with you, so no problem. Okay, any other question?
Thank you, sir.
So regarding the assignment, any assignment?
I think I've said so many things about this assignment. I think somebody was also asking in the group. Yes, the assignment is there, but the assignment, I don't think you should. I'm not saying it is, please don't misquote me. I'm not saying it is not important. Okay? But please focus more on your work.
Sure, we are doing.
Okay, focus more on your work. If the assignment is due or if it's extremely needed, they will get in touch with you.
Sure.
Then what is there in the assignment? It's not a matter of doing some personal findings, go online, read about certain things, and prepare a report and submit. It's as simple as that.
That's right.
So, but this particular class and Saturday classes, please concentrate there, concentrate on those classes, pick whatever you need, apply it in your research work, and finish as soon as you can.
Okay, thank you, sir.
If your PhD program is 3 years or 2 years, if you can finish earlier, it's better.
Okay.
Finish earlier and be waiting for your publication or waiting for graduation day is always the best.
Okay.
Because if you wait till if you're thinking that you have more time, more time. At the end of the day, you realize that you cannot finish within that stipulated period, maybe 3 years or 4 years. So it's better for you to concentrate on it now, do it, finish it as soon as you can, and you're good to go.
Oh,
so regarding the assignments, if you can do now, do. Just go and I think the topic is there, right? It's fine. But if to me, I think you should start thinking about your research work. Then think of how to lead a paper. Think of how to write your research proposal. From your research proposal, think of how to lift a paper from your research proposal. And think of how to publish. Because those are the most difficult parts of your work. Publication. Some of these people, some of these outlets, some of these research outlets may not accept your paper easily. And even if they accept, they may take years before they get your work published. So those ones are more, those ones are more difficult. Those ones are more challenging than assignment of within the school. Whatever you are doing within the school is okay. You can do that anytime. But it's better for you to concentrate on your work now, leave the publication, publish out. Then, if the assignment is a requirement, it's a graduation requirement, it's fine. You can do that within a day or two. You can do that one and submit.
Okay, thank you, sir.
Okay, but you cannot do your research in a day or two. That's the truth.
That's right.
So please put your strength, channel your strength to the right place. That is your work. Channel your strength to the right place, which is your work. Assignment, you can come back to the assignment later and get your assignment done and submit. Assignment can be done within a day or two, but your research work cannot be finished within a day or two. That's why I don't want you to put so much focus on the assignment. You can do your assignment anytime, but focus more on your research work, establish it, and get the work done as soon as you can. Assignment, so what to do about that? That's the same thing we are discussing. But students portal says about the assignment, so what to do about? I don't understand. Is it that if attendance is over 90%, the assignment will be waived? This one I don't know. Okay, I don't know. The attendance at this stage, I don't think the attendance is just sure that you attended the class and you learned something that will assist your research, that will assist you in your research journey. Okay, of course, you're a PhD candidate, right? Nobody will chase you up and down and be saying that, please, you have to attend. No. If you want to finish on time, no problem. If you don't want to finish, nobody will push you either. Okay, even undergraduate students, they don't push them anymore. So nobody will push you, but it's just the university just only trying to the university is only trying to make sure that they engage you because they want you to finish on time. That is why they put all these attendance clauses and all these classes in. That's okay, this class should be able to guide you. And if you have any challenges, you can straight away ask and expose you to those IT tools that can be helpful in your research work. So because if you are working manually, of course, it will take longer time. But if you are using all these IT tools, it will make your work faster. Okay, so that is why they are trying to expose you to all these things, and they are trying to make the attendance compulsory so that when you attend the classes, you will get familiar with all these things. You'll be able to apply it in your research, or then you can finish as soon as possible. We are not interested in delaying you whatsoever, but the only thing is that we cannot write for you. Okay, we cannot do your research. It's your work, not us. So we cannot do it for you. You have to do it yourself. But we are going to provide you with all the necessary support to make sure that you get your work done as soon and complete it as soon as you can. And that's why they are putting all this attendance in there. Okay, at least if you know that the attendance, at least if the attendance is below 40% or below 90% or below 80%, you are not doing us. You are only affecting yourself because you'll be the one that will be spending more time to get your work done. Okay, so we are not interested in delaying you whatsoever. As a matter of fact, we want to finish as soon as you can.
So publication, where we have to do? Publication we need to do in which country?
No, any country. Publication is a requirement for graduation.
Okay.
Publication is a requirement for graduation. Without publication, you cannot go to, you are going nowhere.
Okay.
And this is not only to Lincoln, everywhere it's like that. So publication, you can publish in any country, but wherever outlets you are publishing, whether Springer or any journal, the journal must be Scopus Index.
Okay.
Now, it's either Scopus Index or ISI Index. There's ISI, there's Scopus Index. If it is ISI is a bit more difficult than Scopus.
Okay.
But if you can get ISI, it's fine. But if you cannot get ISI, Scopus is fine. Whether tier 1, tier 2, tier 3, we don't care. But as long as it's Scopus Index, publish in Scopus Index. Okay? Then once you are done with that, then you are good to go. You have fulfilled the requirement. That's one of the assignment is not a graduate requirement though.
Okay.
So please channel your energy to the right task. That's what I'm trying to say.
Can we finish if we are ready with our documents and everything? Can we finish before 3 years or it's a minimum 3 years?
There's a requirement. There's a requirement for graduation from the Ministry of Education.
Okay.
Okay. So the minimum, based on your offer letter, they will have stated it there. Because of course the minimum requirements varies from program to program. Okay. Some are 2 years, some are 3 years.
Okay.
So if you finish before that 3 years,
okay,
you cannot graduate, but at least you have fulfilled all the graduation criteria.
Okay, yeah.
So you have fulfilled all the graduation criteria, then it's not left for the university to clear you when the time comes.
Okay.
I finished my PhD in less than the minimum duration.
Okay.
So, but I had to wait for about 6 months.
6 months?
Yes, I finished this month earlier. So I had to wait. So after the 6 months elapsed, only then I was awarded completion letter.
Sir, okay, you waited for 6 months, but did they approve your Viva and everything? Then you waited. Yes. Everything was approved, just you are waiting for this acknowledgement, right?
Yes.
Okay. So we'll have peace of mind before 6 months only. If we are done with everything, we can wait for 6 months, but we'll be having a peace of mind. We are done with PhD.
Please, hold on, please. I'm not saying that I didn't do my PhD in Lincoln. Okay. Then again, if you finish earlier, you will only be scheduled with the next Viva session, because we normally have all these Viva session, maybe every 3 or 4, every 6 months.
Okay, okay.
So let's say you finish earlier, then you can be scheduled, we will be scheduled with the next set for Viva.
Okay.
So once you are scheduled with the next set for Viva, you do your Viva, all your documentation is done, but you still have to wait.
Okay, okay.
Until you fulfill that minimum requirement. But it's good because you have already done your part. Nothing is delaying you. You're only waiting for the time to elapse.
Okay.
Which is always good. But if you fail to finish within that stipulated time, you have to extend. Then you now be on unnecessary pressure.
Okay.
There will be some kind of pressure on you. So you at the beginning, you may you just be stressed, and that's why you see PhD people and PhD scholar now look a little bit unkempt, something like that. Then you'll be like, your head is, eating up. So that is why it's better for you to do it and get it right from the very beginning.
Okay.
Once you do it and get it right from the very beginning, believe me, you have a smooth research journey.
Okay, thank you, sir. Thanks a lot.
Welcome. Thanks a lot for the blah 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 blah. Advice remind me about the website where I can access statistical information I can apply into my research. What do you mean by statistical information? I don't even understand what you mean by statistical information. What do you mean by statistical information? Are you talking about statistical data, research data, or what? Mr. Agri. Data. I think we have discussed about this, right? We have discussed about this. I think that was in 2 classes ago when we were talking about 2 or 3 classes ago when we were talking about academic research engines. I think I shared some of the search engine where you can get research data. I think I shared this with you. So please check our slide on search engines. Okay, when you check on that, there's a particular slide where I've mentioned where you can get academic, research data. So you just have to go to this link, then choose any of them, then search for your keyword, the kind of data you're looking for. And if you can get it there, then that will even be faster. If you can get the research, if you can get the research data from that platform, then all you need to do is just clean the data, then run whatever analysis you want to perform, interpret your results, and you get your work done, do your writing, and that's all. You can even get your work done get it done faster than you ever imagined. But it's just a matter of you sitting down and search for the right decision, for the right resources. And once you get the right resources, then you're good to go. Okay, I hope I answered that, right? Please, the solution to that, check our previous slide. I think 2 or 3 slides. The slide on academic search engine. You're going to see, when you go through, you're going to see a particular slide where I've mentioned links where you can get research data. Okay, so I think that's all we have for today. Thank you. Stay safe and see you again next week. Okay, bye.
Thank you, sir. Bye-bye. Thank you.
Thank you, sir. Bye-bye.